Hi, today we're going to learn about the perpendicular lines. Okay, to determine when the two lines are perpendicular. So first of all, you know that perpendicular lines are the lines are at the right angles, 90 degrees to each other. So look at the example here drawn for you already. Is y equal x and y equal negative x. These two lines actually perpendicular. They meet at 90 degrees. So now I'm going to take you to the online graphing and to show you actually how you can determine when the two lines are perpendicular. Okay, so in this one here, I guess for you the line y equal to x plus 1 is the red line. And the line y equal negative 1.5 x plus 3 is the blue line. These two lines actually are perpendicular. So when you look at the lines, straight line will look at the radiant and the y-intercept. Okay. So now I'm going to test you now. If I change the value of the y-intercept, what will happen to these two lines? Are they still perpendicular? So now I'm doing that now. So if I change this one to is number 2, what happened? They still perpendicular. If I change this number y-intercept, the first equation I change to number 3. They still perpendicular, isn't it? So if I change this one to number 1, they still perpendicular. So that means the two lines are perpendicular is not affected by the y-intercept. So now we look at the radian. So if I change this radian here, I change this to number 1. They're no longer perpendicular. So I change this to number 3. It's not perpendicular. If I change this to number 5, that's not perpendicular. So only perpendicular when I change back to number 2. So I would like to look at that one carefully here. And the y equal to x plus 1 and the y equal negative half x plus 2. So actually the radian will affect the whether the two lines are perpendicular or not. So I would like to show you this. And you look at that equation 2 here. So and I show you on the online graphing, and you see here is the y-intercept is not affect the two lines perpendicular. Only the radian affects. So what do you figure out from these two values here? What you figure from here, this one m. Okay, that's one m. That one also m. Okay, I can call that one m1 is for line number 1, and I call that one m2 for line number 2. What do you think about number m1 and m2? What's the radian of line number 1 and radian of line number 2? Is any connection there? Yes, there is connection in there to determine whether two lines are perpendicular. So let's look at that. So if the two lines are perpendicular, only what? m1 times m2 equal negative 1. So this is the rule. Okay. So if the two lines are perpendicular, that means the radian of line number 1 times the radian of line number 2 gives you negative 1. And test this one here. So what 2 times negative half, 2 times negative half equal negative 1. Yes. That's why the two lines are perpendicular. Okay, now I go to some example with you, okay? So first of all, you look at this one here for me. It's on the left hand side here. So example number 1. To find the radian of the line perpendicular to the line y equal what? 3x minus 4. So another word you can say here. Okay. So m1 times m2 equal negative 1. So if you look for m1, for example, you look for m1. So I can rearrange the equation here. m1 equal negative 1 over m2. Okay. So that's the same formula. I can rearrange it. Okay. Now, you see the key word here is mean perpendicular. When perpendicular, you think about this formula. Okay. So look to the line. What m here? M here is equal what? 3. So I call that one M1. You can call that one M2. Doesn't matter. You call that one M2. So M2, I call negative 3. I mean 3. So your M, it means you look for the radiant. When you find the radiant, I call that one M1. Okay, your radiant is called M1. So the M1 I call what? M1, I call negative 1 over M2 with a negative 1 over 3. That's your answer. Very easy. Okay. So if this line is radiant in 3, your M should be negative 1 over 3. Negative reciprocal of that, the radiant here. Okay, you're done with that? Now I give you a second example here. Perpendicular line. Think about this. M1 times M2 equal negative 1. Or you can write M1 equal negative 1 over M2. Okay, you can use these two formulas. Now look for the example, the second example here. Show that the line joining the points A, phi 2 and B, 1, 3 is again perpendicular. Okay. You think about this formula here again. To the line joining the point M, 12, 8 and N, 10, 0. So what you have to do here? That means I have to show you that the line AB. Okay. Perpendicular to the line MN. You have to show that. So the perpendicular, that means what? That means M of AB times M of NM has to be equal negative 1. Okay, that's a rule. That means the radiant of the line AB multiplied with the radiant of the line MN should give you negative 1. If this happens, and then the line AP perpendicular with the line MN. So we have to solve it. Okay, first of all, work out the M of AB. So M of AB equal negative 2 y2 minus y1 over x2 minus x1. Use the same step. You label for me here. That one x1, that one y1, x2, y2. We done this one before. Okay. So we put a minus here first for me. Okay. So that means y2 is 3. 3 minus y1 is 2. 1 minus 5. That gives you 1 over negative 4. So you can write here is negative 1 over 4. Okay. Now the second layer you have to find with M of Mn. Equal again y2 minus y1, x2 minus x1. The label with the same thing. That one your x1, y1, x2, y2. And then you put the minus here for me. Your y2 is 0. Your y1 is 8. Your x2 is 10. Your x1 is 12. You do the same for me here. So you got negative 8 minus 12 gives you 4. Okay. Now you put together for me. So can you do that for me? So do for me M, AB times M, sorry small m, M, Mn is equal, MAB is here, negative 1 over 4. You times with Mn is 4. That gives you negative 1. So yes, they give you negative 1. That meets the condition here. So you can say therefore, the line AB perpendicular to the line MN. Thank you very much for watching the video. I hope you enjoy the video and please share with your friends. And thank you.